Hi, my name is Paul Sarimella, and in this video I am going to discuss the projectile motion. Well, before we go into the lesson, once we shall look at the objectives of the today's topic. Okay, so here I have three objectives the student should achieve at the end of the lesson. The first one is the student has to describe the projectile motion. The second objective is the student has to state the types of the projectiles, and the third one, student is able to derive the Su-Watt equations for the horizontal projectile. Okay, we shall look at now what is a projectile. In our daily life, we can see that vehicles can have horizontal motion. For example, a car is going on a road or a flat road, then the car is said to be having the horizontal motion. And sometimes the objects can have vertical motion. When you throw or when you release something from a height, the object falls down vertically downwards. In that case, the object has only the vertical motion. Now, if you look at the projectile motion, in a projectile motion, any object, it will contain the horizontal motion as well as the vertical motion simultaneously. Here, I would come up with a definition of the projectile motion. The projectile is any object that is launched into the air, and the only force acting on the projectile is the gravitational force. So, here the definition is very simple to understand. Projectile has to be any object which is launched into the air, and the only force acting on it should be the gravitational force. Now, let us look at some of the daily life examples. So, here I have an example. An athlete is throwing the arrow into the air. So, the moment the arrow thrown into the air, this will become as a projectile because the only force acting there will be the gravitational force. One more example, here is a biker who is doing a performance. So, here the biker is leaving one of the ramp and traveling into the air and again landing the other ramp other side. Now, if you could look here carefully, the biker and the bike together will be a projectile because the only force acting on them is a gravitational force, right. Here we can see a wrong strategy often applied by the students while they play in a park. Here you could see there are two students. One student is holding the gun with the water balloons while the second student is hanging over the tree. Now, the first student is aiming to shoot the second student there. Now, the second student thinking inside that the water balloon will travel straight and it will hit him. So, now in order to escape from the shot, the second student he is releasing himself from the tree and dropping onto the ground. But eventually the water balloon is traveling in a curved path and then hitting the second student. Now, in this case, from this story we have to get the 2 points. One is the water balloon which is released from the gun is an example of the projectile, and second one is the water balloon cannot travel in a straight line forever. This water balloon has to take a curved path and it has to reach towards the ground. It is because on any projectile the only force acting is the gravitational force, which is always acting vertically downwards on any of the object. Now, let us look at the vocabulary. So, here the projectile is a water balloon, and remember that the path taken by the projectile. So, the path taken by the projectile is called as the trajectory of the projectile, and usually these trajectories are parabola in shape. It means the trajectory will be a U-shaped curve. So, now we shall look at the new vocabulary. The first one, projectile. What is a projectile? The projectile can be any object which is launched into the air and moves with the only force called as the gravitational force. And second one, the trajectory, the path taken by a projectile is a trajectory. Usually these trajectories are parabolas. And parabola meaning also given, parabola is the U-shaped curve. Let us look at how many types of projectiles are there. There are two types of projectiles. The first one is the horizontal projectile and the second one will be the angular projectile. We shall look at the differences between the horizontal one and the angular one. Well, the horizontal projectile is a projectile which is traveling horizontal direction initially. In other words, if you launch a projectile in a horizontal direction, then it is called as a horizontal projectile. So, this projectile is initially traveling in a horizontal direction and then it is falling towards the ground. The second one is the angular projectile. The angular projectile which is launched at an angle theta to the horizontal. So, from the ground level or to the horizontal, this projectile is launched at an angle theta. So, if you could look at the examples for the angular projectile, we can take a person kicks a football into the goal, it can be example of the angular projectile, or else a basketball player pushes the basketball into the basket, or else a basketball player pushes the ball into the basket will be the example of the angular projectile. Now, look at the examples for the horizontal projectiles. So, this can be if a person is releasing an arrow from the bow, the arrow which is released into the air will be the angular projectile, and a person firing a gun, the bullet can be the horizontal projectile. Now, we shall look at how to investigate the projectile motion. So, here we require some of the previous knowledge to investigate the projectile motion. The first one is the kinematic equations of motions. We know that there are three equations, the popular equations for kinematics. First one is V equals to U plus AT, and second one is V squared is equals to U squared plus 2AS, and the third one is displacement S is equals to UT plus half AT squared. So, these three equations I will write on the board later, we have to use for the projectile motions to investigate the motion. We should also recollect the vector additions and the resolutions to investigate the motion here. And oftentimes we have to recollect the Newton's laws of motion so that we can easily investigate the motion. Now, here I would like to go with the investigation of the horizontal projectile. So, here I have the projectile which is launched from a height h and the initial velocity v, or the projectile is following the trajectory here. Now, if you could look here, the velocity, since the velocity is a vector quantity, I can resolve the velocity into the horizontal component and vertical component of velocities. So, in this case, the horizontal component of velocity is taken as a Vx and vertical component of velocity is taken as a Vy. Now, Vx is always constant throughout the journey. If you could look here the arrow lengths which represent the magnitude of the horizontal initial velocity, these arrows are always constant there. It means in a horizontal direction the velocity of the projectile is constant. In other words, in the horizontal direction there is no acceleration for the projectile. How? Well, once we have to recollect what is the only force acting on the projectile. We know that already the only force acting on the projectile is the gravitational force, and the gravitational force always acts vertically downwards. It means in the horizontal direction there is no force acting on the projectile. So, in that case, in the horizontal direction it cannot have any resultant force. From the Newton's second law we can say that since the resultant force is 0, there will be no acceleration in a horizontal direction. So that is why in the horizontal direction the projectile is maintaining uniform velocity. So in this case the Vx is uniform. The second one, we shall look at the another component of the velocity, which is vertical component of velocity. The vertical component, however, initially it does not have any vertical component, because at the maximum height or at the point where you release the projectile, it will be a free fall. We know very well, when an object is falling freely downward, its initial vertical velocity is 0. The same thing applied here. Initial vertical velocity is 0, but its velocity is increasing and keep on increasing as the time goes on. So here, as a projectile is reaching the ground, the vertical component of velocity is keep on increasing and becoming maximum before it reaches the ground. So here we are going to investigate the horizontal projectile motion. So here I have the diagram. We can see that an object is launched from a cliff whose height is h and with the initial velocity of the u, and this object has taken a trajectory along with this parabolic path. Now, since velocity is a vector quantity, I can resolve it into the horizontal component of velocity as well as the vertical component of velocity. So now, the horizontal component of velocity is always constant, because in the horizontal direction the acceleration of the projectile is 0. Well, however, in the vertical direction the acceleration cannot be 0, because there is always the gravitational force acting on the projectile in vertical direction. So the gravitational force acting on the projectile, and due to this force there will be an acceleration of plus 9.81 meters per second squared on the projectile. Now, initially the vertical component of velocity is 0 here, because it is a free fall at this point, but after a while the projectile gains vertical velocity and this velocity keep on increases, and before touching the ground it will be the maximum vertical component of velocity. Now here the height of the cliff is taken as the h, and the total range the projectile is taken as a range r, or we can also take it as the range s. So here the s indicates the horizontal displacement. Now once recollect the kinematic equations of motion, the first one, v is equals to u plus at and v squared equals to u squared plus 2as, and s is equals to ut plus half at squared. So as we know that u is the initial velocity and v is the final velocity, and a stands for acceleration and the t stands for the time, and the letter s stands for the displacement or the distance. Let us investigate the motion in the horizontal direction as well as in the vertical direction separate. Well, in the horizontal direction we know that the acceleration of the projectile is 0. Since the acceleration is 0, I can write that one here in the Suvat equations. A is becoming 0 here. Now since the A is 0 here, I can now derive the equation for the horizontal displacement, nothing but the range of the projectile, that is s is equals to ut plus half at squared. Since the a is 0 here, this whole term will become 0. So now I can write this formula as only s equals to ut. So where I can erase this formula and leave it as only the range s is equals to initial horizontal velocity times t. Now second one, we shall go to the initial horizontal velocity. So u can be written as, by using this formula I can rearrange it as u is equals to range over t. So here the u stands for the initial horizontal velocity, which can be equals to range over the total time taken. Now, we shall look at what is the final velocity in a horizontal direction. So, that v is equals to, we know the formula, v equals to u plus at, v equals to u plus at. So, by using this formula, we can get this one as the v is equals to u plus at. In this formula, my acceleration a is becoming 0. So, I can, this whole term becomes 0 there. So, v will be equals to u. So, in other words, in the horizontal direction, the initial velocity is same as the final velocity. That is what we have indicated by using the arrows here. The horizontal arrows are always constant. It means initial velocity u is same as the final velocity v here. Now, finally, the time taken for the projectile. So, that will be, I can write this one by using the first equation, that is t is equals to range s over u. Now, let us analyze the motion in the vertical direction. So, here again I will write the SUVAT terms. So, SUVAT, S, U, V and A and T. Fine. So, in the vertical direction, the projectile is a freely falling object. It means there is no velocity in vertical direction. Okay. So, I can write this one, the initial velocity in a vertical direction is becoming 0 there. However, final velocity can't become 0 because initial 0 velocity is there, but the final, when you, the time is going on, the velocity of in the vertical direction increasing and increasing and increasing and maximum here. So, the final velocity can't become 0, but only the initial velocity in vertical direction is 0 there. Now, the a value we write here, the acceleration in the vertical direction will be the plus 9.81 meters per second squared. Right. So, by using this information, we can deduce the other equations. S equals to ut plus half at squared. In this equation, the u is becoming 0. So, this whole term is becoming 0. So, now my equation will be the S is equals to half at squared. The next one, we shall write the equation for the final velocity in vertical direction. So, which might be indicating this one here. So, that is v is equals to, we can use any of these formulas, u plus at. So, if I use the first formula, u plus at. So, v is equals to u plus at. In this one, my initial velocity u is becoming 0. So, I can write the formula as v is equal to at, which is same as the gt also we can write. Now, finally, we shall look at the time taken for the projectile in a vertical direction. So, the time taken for projectile will be t equals to, by rearranging this formula here, I can write 2s divided by a. So, square root of, right. So, here the t square is there. So, when you rearrange the formula, we get the 2t square equals to 2s divided by a, but when you remove the square on one side, you will get the root on the other side, that is t is equals to square root of 2s divided by a. This can also be written as t is equals to square root of 2h by g. It is because the displacement here in the vertical direction, which is also called as taken as the h. So, the vertical displacement s is a h here I am writing, and the acceleration value can be the plus g I take here, which is acceleration due to the gravity. So, t is equals to square root of 2h by g is a value I get the. So, t equals to square root of 2h by the g is the final equation I get for the time taken. Now, remember that for any projectile, the time taken in the horizontal direction will be same as the time taken in the vertical direction. It means the projectile can have the same time in a horizontal direction, vertical direction. So, if you can find one time calculation, if you could find one of the time here, the time we can assume the same for the second also. Well, this is all about deriving the equations for the horizontal projectile separately in horizontal direction and also in the vertical direction. Well, I hope you got this lesson very clearly. I will come up with another lesson in my next video.